Hopefully you can hear me all right. How's it going, Elmo, Pog, and Stilltree? Good to see you guys. Today we are going to be diving into Vulkan. So I figured it'd be a nice change of pace, and I've been meaning to like try and draw a triangle with Vulkan for a long time. I figured, you know, may as well try it out on stream so you guys can see me struggle. I'm hoping it won't be too bad, but I found this tutorial. It was recommended on Vulkan's website. Looks pretty solid. I will go through it, and I may skip stuff as I see fit, but we'll see how far I get. How's it going, Garlfin? You've been trying to learn Vulkan, but every time you want to try, you end up hanging yourself. I hope not, but I'm hoping it'll be somewhat okay. If you guys want to check it out, I will paste this link in the Discord chat. This is the repository I'll be using for this stuff. I've already set up like just the basics. I've downloaded it. This is not cross-platform because the way they recommend downloading it, you had to just download the SDK and then put it on your system. I think there's like this thing called Vulcan Loader so that I can have it automatically download it if you don't have it on your system, but that's besides the point. This is just learning, so I don't care about that stuff. But yeah, we will take a look at this. Goal is to get a triangle up by the end of the stream. We'll see if we get there. And just real quick too, before we start that, I do just want to say I have continued working on the math animation editor. This is kind of what I've gotten. I know in the last stream we were working on this project thing, and then you can ignore this project. But anyways, we were working on this project splash screen thing where you can like click them. So I don't have it so you can delete projects yet, but you can click here, create a new project. So I can do like new project 10, I don't know. And then you can create a project, opens up a blank screen. You can add tracks and start adding stuff. Everything is very broken right now, so it's not actually going to work right if I say add a square. Yeah, nothing's really going to work right. So I'm kind of fixing things up right now. But basically, and then if you close, it saves a screenshot, saves the project, and then if we were to launch that back up, you can see we've now got new project 10 down there, and then we can also double click and just jump in there to open it up. And whatever, so like if I have this saved here, I'll blow that up a little bit, it should save the last screenshot of whatever you've been working on, and that's what it displays in the project splash screen as you're looking here. So you can see it just shows that. And that's good enough for me. So like it's a little project selector. I'll probably add to it as time goes on, but just want to let you guys know where it's at. And I'm working on SVG bounding boxes right now, which is why there's all that weird stuff going on. Anyways, though, that's just a little update for those of you who are curious about that. Let's talk about Vulkan. So, and just a little bit of context, I've never done anything with Vulkan. I do know a lot of graphics concepts like, you know, render pipelines, all that stuff. I know about them. I've never done anything in detail with them. I know what a swap chain is. I've never done anything with, I've never built a swap chain, never done anything like that. So I'm hoping the concepts won't be too hard for me to pick up, but we shall see. And then just to show you guys what I've got here, I literally just have a few libraries, GLM, Jilf, Vulkan. If I launch this, it's just an empty window. It says Vulkan begins. Since this is my beginning with Vulkan, I've got my utils library so I can do memory tracking and stuff like that. Just a vendor impls, which is implementations for that stuff. And then this is the app, which I'm doing it in kind of a C style. We'll see if I like this or not. No pun intended. But I'm doing more of a C style today, so trying out like the VKB for Vulkan Begins app. And I'm just kind of curious how I'm going to like this. So trying a few different things since this is just a new project, you know, doesn't matter. Okay, so yeah, there's all that stuff. This is just what's in there setting up the development environment. All that's going on here is we include Vulkan to make sure it's working. Jilf, we create a window, nothing new there. The only thing that's kind of different here is we say no API since we're using Vulkan, so Jilf can set it up correctly. And then I call this function, which gets us how many extensions I have supported on my machine. And then this is just something they had in there, I assume, to make sure GLM works properly. Then we do a window polling loop. Simple. We don't have Jilf swap buffers because I think we're going to handle that ourselves. And then we have our free, which destroys the window and terminates. So how do we draw a triangle in Vulkan, though? From what it looks like in this overview, drawing a triangle is pretty difficult. So these are the steps they've kind of laid out for us. And these are the steps we're going to attempt to finish. I may change things up a little bit. We'll see. But yeah, basically we create a VK instance, select a supported graphics card. So that's pretty cool. You can actually query for like how much VRAM is available and stuff, which I am interested in. That already makes me kind of like Vulkan because that's kind of cool. I'll probably change my mind by the end of the stream. Then we create a device and a queue for commands, I guess, and the device you're using. Create a window surface, swap chain. So we've got the window already because that's just kind of setting up basic stuff. The window surface is just like your display, as far as I understand. And then swap chain is like setting something up so that you can do double buffering and everything. Wrap the swap chain images into a VK image view, create a render pass, frame buffers, set up the graphics pipeline, allocate and record a command buffer, and then we draw the frames by acquiring images, submitting the right draw command buffer, and returning the images back to the swap chain. So, like they say here, it's a lot of steps. We'll see how it goes. So I'm going to go back into setup, and this is kind of the first tutorial. I'm a little bit paranoid real quick because it looked like, okay, I was just making sure that my screen over here on Streamlabs is up to date because it looks like we're going Inception mode too. It just looks like for some reason it may not be updating properly. So if I don't respond or anything, that's probably why. It's just my chat is not updating for me correctly. But yeah, so let's just kind of jump into this and we'll see how it goes. Okay, so in the previous chapter, we set up a Vulkan project. Now, this kind of stuff I'm probably going to kind of skip. Like I said, I'm going for more of a C style. I've already kind of set up a little app namespace thing. That's all he's doing here is just creating a little wrapper so that this stuff is just all abstracted a little bit. I did that a different way. I don't think it really matters. You know, it's the same thing. We have a main loop in it, run free, same thing. So don't really care about that. Let's just kind of check through this stuff. And why Nako? I hope I said that right. How's it going? Good to see you. Okay, so it says program wraps itself into a class. We call init. We call the main loop. We call cleanup. Yep. Okay, it says it will throw a stood runtime error. I don't really care about that. With a descriptive message, which will propagate back to the main function and be printed to the command prompt. We can do that other ways. It's fine. I've also got like my library. I can just, if I want to, for whatever reason, I can just say glogger assert false. This assertion failed. And that kind of does what I would want anyways. So now if we were to run this, we would just fail this assertion. We do. You can see it says this assertion failed, tells us which line and file. And then if I were to continue this, I also get an exception, which says critical assertion failure, tells us which line and file it's coming from, and it gives us the message. So, and then it aborts the app as well. So, yeah, I'm fine without exceptions. I think assertions are just fine for that. Resource management. And there's other ways too. I can like intercept the assertion error and then like save stuff on exit, all sorts of stuff if I really wanted to. But anyways, resource management, just like each chunk of memory allocated with malloc, requires a call to free every Vulkan object that we create. Okay, so yeah, this isn't anything big. Yeah, so just like malloc and free, that's pretty basic stuff. After following this tutorial, you could implement automatic resource management by writing C++ classes that acquire and release them. Okay, so that's, yeah. So fine. I don't care about that too much. Vulkan objects are either created directly with functions like vk create or with functions like vk allocate. After making sure an object is no longer used anywhere, you need to destroy it with counterparts vk destroy and vk free. Okay. The parameters for these functions globally vary for different types of objects, but there's one parameter they all share, p-allocator. This is an optional parameter that allows you to specify callbacks for a custom memory allocator. That's cool. We'll ignore this parameter in the tutorial and always pass null pointer as the argument. Ooh. Okay, so that's pretty cool. So I think this is like so that I could track the memory management as I see fit too and just pass it to my memory management library and then kind of figure out if we have leaks, which that's actually really cool. I would like to explore that a little bit later. Okay, integrating Jilf W. Vulkan works perfectly fine without creating window if you want to use it for off-screen rendering, but it's a lot more exciting to actually show something, of course. Okay, so we've already got this. Yeah, this stuff isn't really that new. Okay, so the very first call is we don't need an OpenGL context because we are not using OpenGL, so we say no API. Handling resized window, take special care. We'll take a look in that later. Disable it for now with another window hint call. Okay, so that's fine by me. We're just going to set it so our window cannot be resized. Oh, and I still have that assertion. Should probably get rid of that. Let's go ahead and just remove this. I've also got to check my computer out sometime. My fans have been blowing all the time, and I had a problem with my liquid cooler in the past. I really hope it's not that again. So that's something I got to check out. Okay, so that looks fine. We can't resize the window. That's all good. Now all that's left is creating the actual window. Private class member to store the reference and initialize the window. Okay, I don't really care about storing references. We're not using a class. So the way I'm going to do that is exactly how I have it in here. We'll just have a static Jilf W window instance inside of our implementation unit or our translation unit, and that should be fine. Okay, we got width and height, got that all set up. We got all that, that's fine. Cool, and then we go into the main loop, and then we destroy. Okay, I should probably be moving a little bit faster because we got quite a bit to go through, and I don't want to spend too much time on the basics. Okay, so we need to start by adding create an instance function and invoking it in the init Vulcan function. Create instance. Additionally, add a data member to hold a handle to that instance, VK instance. Okay. So I guess the VK instance is like our, and we'll call it static VK instance. And this is our VK instance. This is what we'll call that. I'm guessing, so we don't really need this anymore. That was just to check and make sure we do have it. We can say VK instance equals VK create instance. And we need some stuff. So create info, allocator, and an instance. So if we take a look here. Now to create the instance, we'll first have to fill a struct with some information, of course. This data is technically optional, but it may provide useful information because well-known graphics. The struct is called VK application info. Sweet. So let's go back into here. VK application info. I guess we could call this app info, and that should be capital. Another annoying thing happened to me this week too. My keyboard, my old keyboard, it's somewhere back there. I don't think you can see it. It just completely broke for some reason. And I was like typing, so I'd like hit, that's a bad letter to do, but I'd hit like L, right? And then it would just do a double or a triple tap, and that was really annoying. And I kept thinking my batteries were running out, so I went through like way too many batteries until I finally realized, no, it's my dumb keyboard. And it'd just be like, if I just press some buttons, it would just lag for like 2 seconds and then type a bunch of stuff. Okay, so app info. Monkas. I'm not sure what that means. Why Nyko? You might have to expand on that a bit. Okay, so app info. Let's see. Dot. We've got API version, application version, engine version, app name, engine name, next, and S type. Also, I don't know if it's only me, but the stream is buffering quite a lot. It's an emote. Gotcha. Let me check my stream settings very quickly then, because I might have changed stuff unknowingly. Cannot change these while I am live. Of course I can't. Let me just check and see what I've got it set at. Yeah, I don't think I've changed anything. So hopefully it's not buffering for everybody, but if it gets bad, let me know. And I may restart the stream and we can try and fiddle with the settings a little bit before that. So just keep me updated, guys. If stuff looks weird, let me know. Okay, so app info dot, and we've got all this stuff. Let's just copy what they've got here because no sense overcomplicating it. Okay, so we've got this VK structure type application info. So we're telling it what this app thing is. We're calling this not hello triangle, but Vulcan begins. Version 1.0.0, engine name, no engine. Okay, I'm guessing this is just debug stuff. It doesn't really matter. Oh, cool. You can put your engine version in there too. And then API version VK API 1.0. Many structs in Vulkan require you to explicitly specify the type in the S-type member. This is also one of many structs with a pnext member that can point to information. I'm going to zoom this in a little bit too for you guys. I always forget that that might be helpful. We'll zoom this in a little bit too. With a pnext member that can point to the extension information in the future. We're using value initialization here to leave it as null pointer. Okay. A lot more information. We'll go through those in the next few chapters. Cool. Is this a different VK instance create info? Yeah, okay, so this is a different thing. So then we have a VK instance create info, and this takes in a lot of other stuff. Oh, so he was talking about this create info, which is the next thing. And we have to say this is a create info, and we give it a pointer to itself so it knows where to look for it. Okay, and I guess I should do that. Yeah, that was right there. I did not copy all that. Let's copy all this. There we go. Okay. So we create app info, we create info. The first two parameters are straightforward. The next two layers specify the desired global extensions. As mentioned in the overview chapter, Vulkan is platform agnostic API, which means you need an extension to interface with the Windows system. Jilf has a handy built-in function that returns the extensions it needs to do that, which we can pass to the struct. Cool. So this is usually not how I would follow a tutorial, by the way, too. I would normally just write out all this stuff by hand because I do see the value in that. But since I'm on one screen here, I think it's a little bit easier this way. Okay, so we get the extension count, we get the extensions. So that's all we're doing here. We get the required extensions. And then we just set it here. I am curious. Let's just run this real quickly because we should always strive to try to understand what we're doing. Let's see what this says. So our extensions, what does that look like? If we just drop this into our memory, can we just do that? We can. Cool. Did that take us to the right place, though? I don't think it did. Okay, let's take that memory address. Yeah, that's the right memory address. Okay, so the extensions. It says VK KHR surface, but it does not look like that over here, which is just interesting. Is it down here? I was wondering if we'd be able to see like just a list of extensions somewhere over here, but looks like we won't. Okay, but anyways, how many do we have? We have 2. So KHR surface. And then if we do, let's just take a look at the next one too. And then Win32 surface. Okay, so that looks like not all the extensions on my computer, I'm assuming. Just the things we need for our window. Get required instance extensions. Okay, so that kind of makes sense. These are the ones required to create a context, I guess. I don't know. I got no idea what I'm talking about. We're just taking this in stride. The last two members of the struct determine the global validation layers to enable. We'll talk about these more in depth in the next chapter. For now, leave these empty. Okay. Easy enough. And let's get rid of that. We've now specified everything Vulkan needs to create an instance, and we can finally use the create instance call. Cool. So I am going to give it create info, and we want to give it our VK instance. VK for Vulkan, of course. And we get a VK result. Okay, as you'll see, the general pattern that object creation function parameters in Vulkan follow is pointer to struct. That's fine. That's kind of Win32 API is similar. Pointer to custom allocator callbacks, always null pointer in this tutorial. That's interesting. Pointer to the variable that stores the handle to the new object, which is, oh, okay, so this instance is going to get filled. If everything went well, then the handle to the instance was stored in the VK instance class member. Nearly all Vulkan functions return a value of VK result. Success or an error code. To check if the instance was created successfully, we don't need to store the result and can just use check for success. We're not going to throw any errors though. Whether that's good or not, I don't know. We will just say, oh, and I don't really like this. So we will actually check. I mean, I guess what we can do is say glogger assert results equals VK success. And if it does not, we'll say failed to create Vulkan instance. No need for exclamation points in errors. If it's an error, it's bad. No need to emphasize the badness. It's already implicit. So period works fine for me. Okay, so VK create instance. I'm just seeing what this warning is. Visual Studio doesn't like unscoped enums. Imagine throwing anything in C++. Yeah. I mean, I don't mind it if it's like here, because this is just in the initialization, and I'm assuming they're not using this in a core loop or something. But I guess it kind of makes sense for like initialization teardown stuff. Maybe. I don't know. Checking for extension support. If you look at the create instance, you can see extension not present. We could simply specify extensions we require and terminate if that error code comes back. What if we want to check for optional functionality? To retrieve a list of supported extensions before creating instance, there's an enumerate instance extension properties function. Okay. Okay. Yeah, so a lot of this stuff isn't particularly difficult. Just tedious is what it looks like so far. Okay, so basically what we're doing here, getting the extension count. And I am just going to do this instead. Equals that. That. And then we can just cast it to this. Okay. And this does not like our type. I think I probably have a typo in there. Is that better? There we go. That's better. Okay. So we just allocate that. Let me just take a look at what this is real quickly too. It's a struct. Okay, so it's just a char and spec version. Cool. So yeah, we should be fine doing this. And then I'm assuming we can just go ahead and say enumerate and we pass it. Finally, we can query the extension details. Each extension properties contains the name. We can list them with a simple loop. Cool. So if I just do that, and we don't even need to do .data, and then we say for int I equals 0, till I is less than extension count I plus plus, and since this is a uint32, we'll do that. And then what's he printing out? Extension name. Cool. So we can just say extension name, and we'll wrap this in some quotes and say extensions I dot name. Nice and easy. And then I'm assuming we can just free that memory afterwards because we don't really care about it. Okay. How to enumerate extensions. It may be tedious now, but trust me, it gets way harder later and also way more tedious. Oh yeah, 10 pages of code just to draw a triangle. Yeah, that's why I'm worried I may be going through this a bit too slow. We'll see how far we get, and I can extend it to like next week's stream as well if needed. Oh, we already have an exception. Access violation, reading, location, blah, blah, blah. Okay, what's wrong with this? Oh, that's null. Why is this null? VK instance. Where is this defined? VK instance create info. It's right here. Wait, how is this null? Is this just a pointer? Wait a second. Okay, so this is just a type def to a pointer. So am I supposed to allocate memory for that? What do they do? Here, let me just double check that. No, yeah, we're just passing it by address. So I don't understand how that could be null. Well, no, we're passing a... Wait, okay. So this, if we take a look at this, is just a type def for a void pointer. So we're passing a pointer to a pointer here, which I guess is what this takes in. It does indeed. Okay, I'm guessing that exception, though, is about something else. Let's run it again real quick. So what is it complaining about? Okay, so this exists. That looks like it exists. It looks like we've got garbage there, though. What is this? Create info? Oh, maybe I should zero initialize that. I don't think I did that, and that might be what was going wrong. Okay, yeah, so that was a problem. Cool. We've got this fine. It's all good. Yeah, and the fun begins. Now we're good. Okay, so we got device group creation, KHR display, fence capabilities. We have memory capabilities. We have semaphores and properties and surfaces and protected stuff and debugging. Cool. We've got everything, guys. I think we're good. Okay, checking for extension support. We can check, enumerate. Yep. Oh, that's what we just did. Okay. Yep, and then cleaning up. You can add this code to the create instance function if you'd like to provide some details about Vulkan support. As a challenge, try to create a function that checks if all the extensions returned by Jilf get required extensions are included in the supported extensions list. Okay, well, that's simple enough. Let's do it. Okay, we're going to do the challenges. So static void check for required instances or required exts, and this will be a bool. Okay, so we do that. We can implement it here, and let's just copy this. Yup. Okay. Oh, and I guess I actually want to keep that. Okay, so let's copy this. What exactly do I need here? So we have create info. We have get required instance extensions. Okay. Why is this down here? I think it's just because I didn't realize I was doing that down there. Let's move this up here. Okay, no. Okay, so we have create info. We do need this. Okay, put that there, and then we can get rid of all of this stuff. Yes. And then we'll say g logger assert check required exts. Missing required extension. Okay, so we do that. We don't need this create info. We don't need that. Okay, so then we get the stuff. Okay. And then in here, I guess we can just say, okay, so this is like a double loop thing, I guess. Simplest way, we can just say for int or uint32 required xt index I is less than. Okay, we'll do that, and then we'll loop over this, which is exti. Okay, and then we'll say if we'll say bool found ext false, or I guess true. No, we want to set this to false. Okay, if extensions xti dot name equals, or we can't do equals. If string compare that with our GLFW extensions required exti equals 0, which means they are the same, we have found a required extension. So we have found this extension, and we can say break. And then we could say if not found ext logger error missing required extension %s that, and we'll give it GLFW extensions that. Okay, so we'll do that, and then we will just have like a bool res equals false, or actually we probably want to do this true, and then we can say res equals false, return res. Okay, so why is this not happy? Oh, that's extension count. We want extensions. So just grab that. Okay, so that should check for extensions. If we don't have one, it should assert and fail. Let's try it out, see if it works. It's not running yet. There we go. Did it just close? Okay, that was weird. I think that was a bad window. Okay, I think we're good though. If we do succeed, we'll just say successfully initialize Vulcan. Yeah, fine by me. So do we succeed? We do. Cool. So I'm assuming that's all working out. Just to double check. We'll make sure we're actually going into this. Yeah, so we go into here. Looks like that's all fine. Cool. Okay, that's why I always use designated initializers for those thingies. Yeah, exactly. I use them too, just for good measure. Yep. I don't think C has 0 initializers for this type of stuff, which is kind of annoying. If I was in C, I would do something like this, where you can do like .p application name or whatever, which I think is very cool, and I wish C++ had, but unfortunately it does not. Okay, anyways, so cleanup. We cleaned up. We did our challenge. We're good. Validation layers. Okay, guys. Well, this isn't bad, right? It's been about, what, 10, 15 minutes on that portion? We've got this much left, plus subcategories. Hopefully this is good progress. Okay, so validation layers are just, yep, making sure we're not breaking stuff. Also for profiling and replaying. Here's an example of what the implementation of a function in Diagnostics could look like. Ah, okay. Interesting. These validation layers can be freely stacked to include all the debugging functionality that you're interested in. You can simply enable validation layers for debug builds and completely disable them for release builds, which gives you the best of both worlds. So this is basically just like something anybody could create just by wrapping stuff kind of like that. Interesting. Yeah. Gnarly quack. In C, you can 0 initialize with equals 0. Okay, that's what I thought. Yeah. And then C23 is going to gain C++'s empty brackets. Nice. Deutscher Johnny. I hope I said that right. Or Deutscher, I think. This is like 3% of the work you'll need to have done. Uh-oh. So not good progress. Don't worry. Like I said, we can split this up into another stream next week. Let's say I want to at least get to the graphics pipeline maybe by the end of this. If not, I want to get to the triangle, but I have no idea. Vulkan does not come with any validation layers. They're open source. Cool. There are formerly 2 types of validation layers. Instance and device specific. And we'll see later on. Cool. Okay, using validation layers. Just a coincidence. I've also started with Vulkan a few days ago. Oh, nice. You can tell me if I'm doing something stupid then, hopefully. Using validation layers. In this section, we'll see how to enable the standard diagnostics provided by the SDK. Okay. All of the use for standard validation is known as Chronos Validation. By the way, every time I see Chronos, I don't know if you guys have seen The Incredibles, Pixar. I always think of that because of that one scene in the first movie. So, yeah. I don't know who did it first. We'll never know. Enclosure, immutable Lisp running on JVM. Yeah, it takes longer. Ooh. See, I do like how it is nice in C++ and C using libraries like this, because a lot of the times you just have to do like a lot of pointer stuff, and it does make it easier if you can just use the native API. But if they make good bindings, it shouldn't be a pain anyways. So yeah. C is still getting updates. I thought it had stuck in C11. They are, and I saw a scary article where they were saying we should just break C ABI, and I'm like, it's probably not a good idea. Just don't use C if you don't want like C. I don't know. C is kind of like a glue language more than, yeah. Allocating on stack is quite in Java. Okay, so in this section, we'll see how to enable the standard diagnostics. Nice. Let's first add 2 configuration variables to the program to specify the layers to enable and whether to enable them or not. I've chosen to base that value on the program as being compiled in debug mode or not. The ndebug macro is part of the C++ standard and means not debug. Cool, I didn't know that was in there. This is nice too. I do like that. So okay, we'll just copy that. Simple enough. I'm also going to get rid of IOString because we don't really care about that. And why are we using a vector of const char starts here? This is just a fixed size array. I mean, if anything, we should be using array and then just call it that. Not sure why that was a vector, unless we're going to add more validation layers. But even then, I have a feeling you'll know how many validation layers you'll need before you start. So there's no point in making that a vector. Anyways, it is what it is. Okay. So we are in debug mode. So this is of course, and if I switch this to release, do we switch to this? No, we do not. Okay, I want to reverse this thing because I think we can do if not defined, right? Do we have to do if not defined? There we go. Okay, so if not defined that, now if we go back to debug, that is defined. Okay, so we go here. I like that better. And debug is not in my release mode for whatever reason. So yeah, maybe I don't have debug stuff turned off. Let me just check chat real quickly. ABI by itself is just something else, to be honest. That is true. C23 is looking fairly major change by C standards. Yeah, I've noticed some. It is interesting. Okay, so we'll add a new function, check validation layer support, that checks if all the requested layers are available. First, list all of the layers using enumerate and layer properties. Okay, cool, easy. We'll just scroll down here and put this down here. Static bool, check validation layer support. We'll do that. I'm also gonna start, you know, making this stuff a little bit better, and these have to be the same. You can't do stuff like that where they're different. This is our internal variables. Okay, and then this will be copied down to here. Cool, organization, it's nice. Now for this, available layers. Once again, we don't need to do that. We can just say equals that star. Another reason I'm kind of doing stuff like this is it does force me to kind of understand a little bit more, or at least take a little bit more of a look at what I'm actually doing instead of just blindly copying and pasting this stuff. I honestly don't know what the best way to follow tutorials like this are, because yeah, I don't know. I do like the challenges he provides though. Okay, so we've got available layers, we've got the layer count. So I'm guessing what we want to do is we just want to say for int, we got the layer count, we have the available layers. What we want to do is we want to check and see if we have the layers we're looking for. Bool res equals false. True res, we'll do that. And actually let's initialize this to true. We'll say for int I equals 0, for required layer I equals 0 until required layer I is less than, what did we call this? Validation layers dot size. That we'll do the same exact thing we did up there, and then we will say for int, and I guess this is bothering me. Okay, and I guess we'll call this uint32, and we will say for layer I equals 0 until layer I is less than available layers. Layer I plus plus. And we will say if available layers layer I dot, oh, and we actually want to do layer count. That's better. Okay, so if that dot layer name is what I'm guessing, and we're gonna do a string compare. I also don't like string comparisons here, but I guess like if they're giving us the headers, they could have given us enumeration values. I don't know. I don't know what's safer in this case, because I guess those could get kind of corrupted easily. Anyways, though, So if that's equal to our layers, so if we've got that equals 0, then we have the extension. I suppose what we want to do is we just want to check and see if it's not equal to 0, and then we can say res equals false, and then we can say g logger error, and I don't know, maybe this is just a warning because you don't care if you're technically missing some. We'll error it for now though. Missing validation layer. And we'll give it, oh, and we actually don't want to do this, no. So we do want to say if it equals 0, and then we'll swap this up a little bit. We'll say bool found layer goes to true, false, found layer equals true, break, copy that, if not found layer, and then we want to say we're missing the validation layer. Okay, there we go. So, and then we'll say res equals false. No 0 there. Okay, and that should be good. So then I'm just gonna put that in here. We'll just see if it runs. So we'll just say check validation layer support. Okay, I don't care about the result. We'll see what he does with it in just a second. Okay, it looks like that succeeds. So we do have Chronos Validation. Cool. Sorry, I see my name here. Isn't the hash if def and swapping the then and else branches better than double negation? I honestly don't think it matters that much. I mean, yeah, I guess what we could do is we could just say that. Yeah. I'm wondering if we could even just do like something like that. I think there's a preprocessor directive. At least I thought there was. Is defined or something, like where you can check and see if something's defined. We've got this stuff. Yep, all that stuff. I swear, I don't think I'm is defined. Function directive. I'm pretty sure there is something in here. Let's do MSVC. Maybe it's just an MSVC thing. Yeah, I don't know. Maybe I'm just thinking about this wrong. I could have sworn there was. Wait, let's check the grammar out. Okay. I've got to know now if I'm thinking. Okay, yeah. So there is a defined constant expression. Defined bracket identifier. Yeah. Constant expression. So why don't you like that? Defined is not defined. Well, it should be. Ah, whatever. We can just leave it this way, though. That's fine. And I guess that's probably a little bit better, too. Okay, anyway, sorry. Don't worry, a little bit of corruption isn't that bad. In this case, comes to be a problem. Just say it's an extra feature. What's that they say? You can't code program without corrupting a few bits. Defined is for use in macros. That's what I thought too, but it didn't like it. Oh, hash if defined. Debug. Yep, that's what it is. Okay. Interesting. Okay, so anyways, we've got this. Next, check if all the layers in the validation layers exist. You made it include cstring for string compare. Sweet. So he just did exactly what I did. Look at that, guys. We predicted what code he was going to write. I was scrolled up here, right? I don't think I saw that. I didn't see it. So, cool. We can now use this function and create instance. We don't even have a create instance function. So let's create that. static void create instance. I guess this should return a bool as well. Let's do that. And we'll put that right here. And we'll grab this stuff and move that down. And we'll just say create instance. Okay, and then we'll just paste all that stuff in here. And what's he saying now? If enable validation layers and not check validation layer support, we throw an error. Okay, so that's easy enough. glogger assert missing validation layers. If enable validation layers. Easy enough. Turn true. I guess, yeah, so technically this can't fail. We don't need to return anything. I mean, it can fail, but if it fails, we're crashing anyway, so it doesn't really matter. Cool. So we'll just do that. Good enough. Okay, now run the program. We should succeed. That's good. Finally modify vacate create instance info to include the validation layer names if they are enabled. It's a good point. So... and I'm doing this after we create it, so I guess that's not very useful, is it now? Okay, so we do this. We actually want to create the thing afterwards. So let's actually move all of this down here. And thank you, SMY Dev, for following. Good to see you. I guess that's SMyDev is how I would pronounce that, maybe. Who knows? So we get the result. We check that result. That's all fine. And I guess what we can do here is we can just bundle all this stuff together. So enabled layer count equals validation layers dot size. Okay. And is this the proper way? So what's the difference? I am curious if we have any C++ people here. What is the difference between that and that? They do the same thing, right? It's not like this can't magically fix my buffer underrun. So like if this is for whatever reason greater than a uint32, this is still gonna truncate it. It's just gonna like drop the extra bits, which is exactly the same as what this would do. And so what is the point of this? It's just extra typing. What extra safety am I gaining here? I don't know. Okay. Anyways. We'll go ahead and just do that. And yes, I guess we do need to do .data there. And we'll just go ahead and move that up. Cool. Let's try and run this, make sure we didn't break anything. And if defined, yep. So thank you, Tree, for that expansion on the defined. And from what I know, there's no difference between these casts. Yeah. The safety you're gaining is that the compiler is aware of what you're doing in case you had any warnings turned on. Well, it'll do the same thing too. So like, that's not good. We're gonna have to take a look at that in a minute. It'll do the same thing though. So like if I, for whatever reason, I think I have all warnings on, possibly. Well, yeah, even with this. Okay, if we just look at the output, because I should have gotten a warning here. Let's look at the build output. Okay, no, we did not get a warning there. Because I know I get lots of warnings in my code with other stuff, but let's see. Where is that? That is right here. So this returns a size T, and I am casting that to a uint32. Let's rebuild this very quickly. Yeah, okay, so I see some warnings popping up there, and I think they are referring to that. No. Interesting. I know I've seen warnings about that before, but yeah. In case you had any warnings, I'm pretty sure it would make it stop yelling at you. Vactrol, hey Gabe, I like your videos on algorithms in Minecraft. Thank you. Good to see you. For C stylecast, the compiler apparently tries the various C++ stylecasts until one of them works more or less. Exactly. Yeah, and I'm pretty sure it should be warning me about this too. I gotta fix that too, apparently. But I do remember in my other code bases, I don't think I have warnings turned on all the way here. And I don't feel like bothering looking. But yeah, I do think we do get warnings about this type of stuff as well. If I just go ahead and do this, we can check real quick, because I am curious now. Do we have warnings? Okay, so we got on level 3. If we go up to all, rebuild this, do we get a message? Oh boy, that's not good. There's a lot of warnings here. Probably should have done this a while ago. Okay, never mind. We're not even going to bother with that. I think the warning that comes is if I do... So if we go back here, let's just go back to 3. Is if I don't do anything there, and then it tells me it's an implicit cast, which is basically, in my opinion, the same thing. Like if I just do this, then I should get a warning. Okay, yeah, there we go. Size T to UN32T. Oh, and this is all underneath. I've got to fix my screen here because you guys can't even see that. I promise it is telling me warnings here, so I guess that's how we'll go about that. But yeah, let's just move on. But yes, I think you can see right here, maybe, but it does give me a warning. Okay, anyways, for C-style cast, the compiler apparently tries to vary C++ style cast. With static cast, it tries to cast only if the type is derived from T. It can be promoted, demoted to T, or if it has the cast operator defined, if you remember correctly. It's quite a long journey, but the static cast is more safe and can be used in const expert contests. Okay. I still don't see, I mean, I guess extra type safety is always good. But this is bad anyways. It's like, if you have extra bits, you're going to lose those no matter what. So, okay, anyways, sorry. Let's continue. Message callback. The validation at this rate, we're never going to get anywhere close to a triangle, which is my fault, not your guys' fault. So in the validation layers, we'll print debug messages to the standard output by default, but we can also handle them ourselves. Oh, and did he say we would get anything? Because I do. Wait, sorry. But you should run the program to make sure. Okay, weird. So validation layer print the debug messages to set up a callback in our program. We have to set up a debug messenger with this extension. We'll first create a get required extensions function that will return the required list of extensions based on whether validation layers are enabled or not. Cool. Okay, so this is why he had this as a vector, I believe. Yeah, makes sense now. And I don't see any reason why we shouldn't have that as a vector as well. So we'll just include vector, and then we'll just switch this up. Well, actually, that can stay. But when we're getting the extensions, yeah, we're going to switch to this thing. Let's go ahead. Go up here. Do that and go back down here. Okay, cool. So we get the required extensions here. Okay, then we resize it. Oh, okay, so we pass it that, and we pass it extensions plus extensions count. Oh, we're just passing it a range. Okay, so then we initialize it to this. Should just copy those pointers. Oh, cool. And they've got enumerations for this stuff. And then we just return those extensions. And we will just go ahead and here say that okay, so we do that. And actually I think, no, that is size, okay. And that, and that. And we should be good. So if we run this again, we should be fine. Yep, we get nothing wrong there. So that's all good. So we do have this extension, is what I'm assuming. The extensions specified by GLFW are always required, but the debug messenger extension is conditionally added. Cool. So typos, avoiding them. That's good. And then why Nico? If it's primitives like integers, I don't think there are any problems, but if it involves pointers to types, it can be somewhat of a headache to track. C++ is a beast. I do agree with you there. So many little things that you need to think about, but yeah. You don't actually get to drawing a triangle until the end of the drawing subsection of the drawing triangle, so you're not quite there yet. Oh yeah, and I just realized, okay, that's just comments. I was about to say, there's a lot left in this section alone, but that's good to know. Okay, so we've got the required extensions. Run the program. Yeah, so we've already kind of done that. Wait, are we doing this correctly though? Let me just double check that. So we create the info here. Okay. Where is... Oh, we should be adding... Yeah, we should be adding an extension count. Okay, so that's what they're doing here. Extensions... So that's what they do here with the create info. If we're going to do that too, then when we check, if we're checking for required extensions, we should probably be doing that before we create the thing. So let's do that here. Pass that in there. And this will take in a const std vector, const char star ref, call that. Okay, we'll do that. We'll do that. There we go. And now this should be fine. Okay. So that should create it with the extensions for us. Let's just make sure we're still working. We are still working. Nice. Run the program. We did. We are fine. Now let's see what a debug message callback function looks like. Add a new static member function called debug callback. Easy. This is just like the OpenGL callback function. So nothing new here. The only thing I will change is do that. And I will do that. And then I'm just going to implement it at the bottom of the file. I think this is a Java-ism that I've just kind of carried over, putting private stuff at the bottom of the file. Maybe it is. Yeah, that's the Java thing, right? Where you basically put any private stuff at the bottom instead of leaving it at the top. So yeah, fun stuff, right? Validation layer. Let's do that. And then instead of this, we're going to do /n/t%s. And then we'll give it that message. Okay. So if we do that, I think that message should be properly formatted now. It is not. What does this say? I probably should have looked at that when I first saw this. Value of p, okay, must be null based on the valid. Okay, so I must not be zeroing out my stuff up here. Yeah. Let's do that. Try this again. There we go. That got rid of that. Cool. Okay, so the first parameter specifies the severity of the message. Cool. The values of this enumeration are set up in such a way that you can use a comparison operation to check if the message is equal or worse. Oh, cool. That's nice. The message type parameter can have the following values. The p callback data parameter refers to that containing the details of the message itself, with the most important members being the message, objects, and object count. And this contains a pointer that was specified during the setup of the callback and allows you to pass your own data to it. Cool. So even the debug callback in Vulkan is managed with a handle that needs to be explicitly created and destroyed. Such a callback is part of the debug messenger, and you can have as many of them as you want. Okay, so we are just going to add this guy, which is a pointer. I'm assuming it is. Okay, so we have our debug messenger. Thank you, Luz Eternal, for following. Good to see you. Okay, so we've got that. Set up debug messenger. If this is all it's going to do, I'm not going to... Okay, it does do more. I was going to say, if this is just a one-line function, I'm not even going to bother with that. But let's go ahead. This should be up here. And we will say static bool set up debug messenger. Get required extensions. Let's go down here. And we'll put this guy right there. Okay, and then if that's not there, we don't care. Okay, and I guess this is void. Although I feel like if we don't have it, that should probably be handled, or at least like crashed if we don't have this, because then it probably won't work right, but whatever. We'll need to fill in a structure with details about the messenger and its callback. That's a lot of stuff. Let's take a look at this. Okay, so the type is a debug utils messenger create info ext. Okay, so this creates the information for our messenger, I guess. The severity, we want verbose, we want debug, oh, error warning. Okay, so that's just, I guess, getting all the different severities. We want types, general, validation, and performance. Cool. And then we give it our callback. Nice. User data. Awesome. Okay. That seems pretty straightforward. Man, we still haven't even gotten into this stuff. Okay, this is taking way longer than I thought it would. So, create debug messengers utils ext. Why did I copy that whole thing? Wait a second. So what are we doing here? This structure should be passed to this. Unfortunately, because this function is an extension function, it's not automatically loaded. We have to look up its address ourselves using getInstanceProcAddress. We're going to create our own proxy function that handles this in the background. I've added it in right above the hello triangle application class definition. Okay, so basically we need to call this function to help us out with this, but we don't actually have this function, so we have to create the function ourselves. Okay. Let's go ahead. This is just loading the function, I guess, right? It's basically just like what GLAD would do for us in OpenGL. So what is this? Takes in a VK instance. That guy. Callbacks. And that guy. Okay, let's go down here. So we get the proc address for this guy. And what is this returning us? This is returning us a type def to this. Oh boy, that's a big type def. I guess what we could just say is it is that. Okay, and then we just call it here. So we're basically just wrapping around this, I guess, is what we're doing here. We're getting the address, and then we're wrapping it here. Otherwise, we say it's not present. Cool. So this will return null pointer if the function can't be loaded. We can now call this function to create the extension object if it's available. What is this? Why are we, okay, wait, oh, so that's just returning, okay, I gotcha. So basically, if this extension isn't present, what we can do is just return this enum, which basically tells us, hey, you tried to call this function pointer, which doesn't exist. I do like that, that's cool. So, wait, where's our debug messenger? Is our debug messenger up here somewhere? So we create the instance. And then we create the debug messenger using our instance, our create info, which is right here. It doesn't like this for some reason. We'll take a look at that in a minute. And then we just want to that, which I guess we could just assert that, but it's fine. Okay, so this also needs to be cleaned up as well. So we need to destroy it. Clearly, if we've created it. So destroy, which basically loads the destroy method and then calls it and forwards our arguments. Let's go ahead and do that. Go up here, we'll pop it up here. I feel like these should be in some sort of header, kind of like glad, but it is what it is. Okay, so, oh, and now this isn't gonna, okay, yeah, this is still complaining. So this takes in create info ext, oh, debug util messenger. Yeah, so this should be down inside of this function we were working in a second ago, which was this guy. Okay, so yeah, this should be here. And we do have the VK instance. Okay, cool. So that's all good. Make sure this is a static class. And then we can call it in the cleanup function. Nice. Okay. So that's that. That's that. Okay, and we never set it up. Do we? Create debug util. So we create instance. We do that. And then I'm guessing we probably only want to do this here. Let's see where they do it real quickly. Debugging instance creation and destruction. Oh, okay, no, this is, okay, I thought this was saying debugging whether that's breaking. Anyways, let me just check chat real quick. Vulcan puts the V in verbose. That is true. Templates are amazing. I don't like their compile time, how long it takes to do that, though. That is not amazing, but they are pretty cool. Okay, so although we've now added debugging with validation layers to the program, we're not covering everything quite yet. The VK create debug utils messenger requires a valid instance to have been created. Ah, okay, so it's like a catch-22. Must be called before the instance is destroyed. This currently leaves us unable to debug any issues when we're creating or destroying the instance. However, if you closely read the extension documentation, you'll see that there is a way to create a separate debug utils messenger specifically for those two function calls. It requires you to simply pass a pointer to the create info ext struct in the pnext extension of create info. First, extract population of the messenger, create info into a separate function. Oh my gosh. Okay. So I guess what happens is they're saying technically this function could fail while we're creating it, but in order to create our debugger callback thing, right? Our create debug, we need this thing, which won't get created till we do this. So in order to fix this, what we have to do is we have to create a special debug callback just for this function. I feel like this could have been handled better. I don't know the internals of Vulkan, but I feel like this probably could have been handled a little bit better. It is what it is. This was probably created after they had a lot of initial spec stuff, whatever, set up and everything. So, okay. So first extract population of the messenger create info into a separate function. Populate debug. So this is basically just initializing. I'm not going to call it populate because that makes no sense to me. So static, this is, so we're init debug message create info callback. We pass in the create info here. We initialize this stuff, which is what we were doing here. Okay. So I'm guessing we're actually not gonna do that. We'll fix this in a minute. Okay. And then we have the setup, which... Okay, so we create the info, we initialize it. Okay, so this doesn't look like it's really changed much. Yeah, so that was right here where we had this. Yeah, so we basically, yeah, so this is the exact same thing. We just want to call this init, vk create info. What is this? This one? One of these. I think it's that one. Oh, did I get that right? Okay, I was not expecting. They have too many types. Okay, this is very verbose. But I guess that's correct. Cool. So we do that. We can now reuse this in the create instance function. So now create instance. What we do is we have our create info here. We say this is specifically for this one debug callback that we need to check. Oh, wait, no, this is the instance create info. Okay, let's go up to here. So we've got our create info. I think that's the same. Yep, that's the same, app info. Okay, and then we create some more debug create info. Right, where is that? Here. Okay. Then we do all this stuff that we did. Okay, so then we initialize it. And we set the next field to this guy. Okay. We initialize this with our debug create info. And then we say create info dot next is that guy. And I guess we need to cast that. Why are we casting it here? This is just a void star, so why are we casting to that? Wait, did I get the wrong next? No, he's saying p next. So I think this should be void star. Otherwise, we say create info dot p next equals null pointer, which makes sense. And then we create the instance. Okay, so now the debug create info variable is placed outside the if statement to ensure that's not destroyed before the create instance call. By creating an additional debug messenger this way, automatically be used during the create instance and destroy instance cleanup after that. Cool, I'm gonna test this now. I think I can test this just by undoing this, which showed a message. And so now we should see it log properly. At least that's my hope. Yeah, that's this. Okay. Identifier cannot be found. I do need to do a little bit of this action. Okay, we do that. VK debug instance. What is it called? Debug utils messengers, utils messenger create info. I did not get that completely right. EXT, okay, forgot about the extension. Cool. So now if we are to run this, okay, cool. So now it is running through my logger. Sweet. So this looks like it's working. It's saying validation layer, GUID for 3. Yeah, so it's basically we're getting some garbage in there. It's breaking some stuff because we did not zero initialize this. Now if I zero initialize that, we should be fine. No, we're still getting stuff. Okay, so I've broken something else. We'll have to check out what that's about. But at least it's doing stuff. And Refined Chicken, how's it going? Good to see you. Isn't that like create an OpenGL window on Windows? You need an OpenGL context to get an OpenGL window, but you need a window to get an OpenGL context. That is true. And I think that's a result of the open source API wars in the early 2000s from Microsoft. Not a Windows user myself, so I could be mistaken. No, you're 100% correct. Windows doesn't mess around. No, it does not. The logger successfully logging nothing works, everything's broken. That is true. So we got the logger part right. I guess that's something to be happy about, right? Okay, so what's going on here? GUID for 3 is not software component. GUID for 4 is not software component. What does this mean? Failed to open JSON file. Why are we trying to open Social Club Vulcan Lair from Rockstar Games? Wait, okay, are these my errors? I think I remember seeing something about how Vulcan can be spitting out errors from other people's broken stuff. So are these... Is this mine or is this somebody else's stuff that's just breaking? Because I don't see why Rockstar Games... Yeah, that's what I'm thinking too. What's going on here? Did Rockstar Games make a boo-boo and then this is just popping up in my stuff? I have no idea. ICD drivers. NVO GLV64DLL. Yeah, let's just Google this real quickly because I am curious. Vulcan validation layer complaining about Rockstar Games JSON file. Did they get something similar? No. Here we go. This is one from NVIDIA Corporations. This looks like an incorrect layer set up on NVIDIA's behalf. Nothing they have done should affect any other applications running on this system. I would try to reinstall CUDA and update your graphics driver. Gabe and Rockstar collab. Yeah, not intentional. Tweet at Rockstar Games. Why are your bugs in my Vulcan logger? If only I had a Twitter. No, I'm inclined to believe that this is probably a problem with my implementation of whatever I did. Something is wrong here, but yeah. It is just weird that I'm getting these random errors though that I've got no idea what any of this stuff is about. I wonder if I just have bad drivers or something. Let's just take a look real quick. Do I even have this file? No. Program files, Rockstar Games. You know, this could be a problem with me too, because I might have just like deleted some files from a game that I didn't want anymore and not checked to make sure I didn't break anything. Because it doesn't look like I have Rockstar in here. I think the only thing I ever did have there I deleted, so that's strange. Let's Google one more thing. Vulcan validation layer is from different validation layer on my computer. Reinstall, reboot, pray, standard device. True. It really doesn't make any sense. I wonder what went wrong for this to happen. Yeah. And this is why I don't use Vulkan. Just random crap not working because yes. Really weird on their side then. Yeah. May cause errors. May cause errors. This is just, yeah, very strange. I don't even know how I would get rid of that stuff because it's like... Yeah, I have no idea how I'd even get rid of these. Okay, we'll look into that later. Let's continue on. I'm gonna really regret this. Probably in the future. Now let's intentionally make a mistake to see the validation layers run in action. Well, I don't have to intentionally make a mistake. I've already made one somehow. Temporarily remove the call to destroy debug utils messenger in the cleanup function. Run your program. Once it exits, you should see something like this. Well, hopefully we will see something like that. Okay, so if we go to free, get rid of that. Let's see what happens. Getting errors directly from the cloud, man. The internet is surely, yeah. This is strange stuff happening these days, right? First of all, why do I get a memory leak detected? I must have forgotten to free something. But I did not get an error there too, so that's not good. 169. What am I forgetting to free? That. What is that called? Thank you. Okay. Rockstar Games made a mistake for you. It was the free game from Epic Game Store, so maybe that's why. They were like, you're getting a free game, so we're going to make it break on purpose. Did I remove the call to destroy debug utils messenger ext in the cleanup function and run your program? Once it exits, you should see something like this. We are not seeing something like that. If you don't see any messages, check your installation. If you want to see which call triggered a message, you can add a breakpoint. Ooh, that's a good idea. Wait a second. Let's go into here. Okay. This is coming from here. Which is coming from here. Wait, are these even... Okay, so this is validation layer. Does it tell us what severity this is? Because this could just be like some info stuff, right? Let's just do this real quick. If message severity is greater than or equal to VK... error. Yeah. I mean, I guess we'll just do if it equals. Yeah, and then this will be error, right? Okay, we'll do that. Else if that message severity warning, we'll grab this. Let's do this as a warning. And then if, I guess we'll do a log, which is my lowest log level. Okay, let's see what those are. I'm still confused as to why we're not seeing it end up. Okay, cool. So these are all low. We do have one failed one. Okay, so Rockstar Games is the only error I have here. The rest of them are just informational stuff. That's sad. I don't know what to do about that. We should be getting an error though when we close, but we're not, which makes me wonder if I've messed something up here. Did I ever zero initialize that again after I finished? Let's go back down to here. I did. Okay, so this is zero initialized. So if we enable the validation layers, we do this, we get the size, the data, we initialize it here. Oh, we initialize it here. Wait, is that right? So he has create instance there. Okay, yeah, so we populate it, or in my case, init. But where do we actually create the debug layer? So that initializes it. I'm wondering, am I supposed to be doing after that? What do we call it? I called it something. So this init, that does that part, right? But I swear we had something else. Yeah, this create debug util stuff. Oh, okay. So since I'm never calling this, I don't think it ever triggers it. Oh, no. Set up debug messenger. Okay, do I call this anywhere else? No. Okay, so I think I need to call this set up debug messenger after we actually create the app, which would explain why we're not seeing it error out. Rockstar Games made the mistake for you. Very true. Okay, there we go. Cool. Whew. Okay, I was getting scared. I was like, we've got some more problems than I thought, but that does look good. So now we're getting it, this very scary looking error. Man, they make C++ errors look friendly. Or MSVC, I should say, because Clang and others have some good errors, but MSVC is even better than this, at least. Oh, here's the actual message. All child objects created using instance must have been destroyed prior using instance. Cool. So that's basically warning me, I guess, that I never freed it, which would be here. And if we do that, we should be good. And we're good. Okay, cool. So we have finally done this. There are a lot more settings. That's great. You will find VK layer settings.txt file that explains how to configure layers. Throughout this tutorial, I'll be making a couple of intentional mistakes to show you how helpful the validation layers are with catching them and teach you how important it is to know exactly what you're doing with Vulkan. Now it's time to look at the Vulcan devices in the system. Template errors are still worse, I think. I've gotten used to the template errors at the very least. I can kind of tell what's going on there. This is just gibberish to me for now. It's going to take a while for me to adjust. I feel like I need to parse it and like color things differently so you can actually tell what's going on. But yeah. Let's commit this because this is probably a good point. I want to commit often because I after that and from things I've heard, there are many things that can go wrong like that. So we just finished validation layers. We will push that and we will move on. Selecting a physical device. So after initializing the Vulkan library through a VK instance, we need to look for and select a graphics card. We can select any number of graphics cards, use them simultaneously, but in this tutorial, we'll stick to the first graphics card that suits our needs. We'll add a function pick physical device and add a call to it in the init Vulkan function. This is really cool. I don't think there are many use cases. I don't think many people have multiple graphics cards to choose unless you have like an integrated in a standalone. I don't know what you call it. Integrated in a like an actual graphics card. Yeah. So I'm not sure where this might come in handy is what I'm trying to say. I wonder if you could, if there are people who have a use case where it's like, I want to use this graphics card that I also have on my computer or not. Template errors can be a big pain, especially if you're working with multiple layers of abstraction. That is true. One thing I will say, if you're in Visual Studio, always look at the build window. Do not look at the output. I guess, I don't know, the error list. Yeah, don't look at this thing because the template errors are so much easier to read in like the actual build window and stuff. I'm going to move this. Is that better? No. Let's do a... There we go. Now you guys can kind of see, but then that's going to block the code, so that's not very good. Let me just move some stuff around really quickly, guys. Bear with me for just a minute. Because oh man, there's like no good place to put chat to like not block too much stuff. We're going to move this over here. This over here. We'll see how this goes. And then I can fix it up a little bit later. And you guys will see the changes in just a minute, hopefully. Okay, so we're going to do that. Cool. Now you guys can see over here. I feel like I need to make this stuff a little bit smaller. I'm going to have to like put a to-do somewhere so I don't forget that. Let me grab just a couple other things and move this stuff over just a little bit more to the right. Okay, that's there. Oh man, this is just painful. I don't like Streamlabs right now. Okay. Let's move that there. Okay. There we go. If that's bothering anyone's OCD, it'll be fixed by the next stream. You can disable the error list in the settings. Well, that's not what I'm saying. I'm just saying like the errors that are actually shown in the output window are so much more readable for whatever reason. They give a lot more information than this stuff here, which is weird. Okay, anyways, let's continue. Okay. Selecting a physical device. So we'll add a function, pick physical device, and add it to the call in the init Vulkan. So we do that. Create instance, set up debug messenger, and then pick physical device. Do I have an init Vulkan method? I don't think I do. Oh, this is where we were supposed to put that. Makes sense. And then let's also call this that. Let's actually put that up here. We will go down here. And that. And we will take this out of here. Okay, and then grab this. Do that. Do that. Okay, cool. And then pick physical device. Easy enough. All right, now we're done. Easy. Physical device has been picked. Okay. So we run this. Just make sure I didn't break stuff. We are good. As good as we can be with all those logs. Graphics card that we'll end up selecting will be stored in a physical device handle that is added as a new class member. The object will be implicitly destroyed when the instance is destroyed, so we don't need to do anything new in the cleanup function. Nice. So we have another new member to our Vulkan stuff. Null handle. I wonder why we don't initialize those to null handles too. Okay. Listing the graphics card is very similar to listing extensions and starts with querying just the number. If there are 0 devices, then there's no point in going further. Makes sense. We will say that. Okay. If there are 0 devices, yep. Otherwise, we can now allocate an array to hold all the VK physical device handles. And once again, I am just going to that for no good reason. Okay. And we can just do that. Awesome. So we look through our devices. Now we need to evaluate each of them, see if they're suitable. And we'll check if any of the physical devices meet requirements that we'll add to the function. Okay, so we have requirements and everything. Man, I didn't realize I had to be so picky about my graphics card. I thought any graphics card worked, but I must have been doing it wrong all this time in OpenGL. Okay. Is device suitable? Device, we probably don't want to declare that twice. Check that. Okay. We'll check if any of the physical devices meet the requirements. Okay, easy enough. Then we just loop through. So that's right here. I guess this is UN32. Okay, if that, we just wanna, okay, so if our device is suitable, then we can say our device, what did I call that? Device handle? It's somewhere up there, I can't remember. We called it something up here, physical device. Equals that break and we'll just make sure it doesn't equal that. Failed to find a suitable card for Vulcan. Cool. My opinion, it would be better if you move the top donator and the current topic to the bottom of the links that I have under the webcam, and then I can leave the chat box alone. This way it would feel free a little bit more space for the code consoles, and also probably make the word, make it a little bit more smaller. Talking about errors, I remember, that's a good idea. Here, I'm gonna do this real quickly. And I'm also gonna shrink, whoops, that top donator box a little bit more. So let's do that. And then let's move this up here. It's gonna be a little bit smaller. I'm gonna have to create a new graphic for the background because you can't do like transparent boxes, unfortunately. So we're gonna do that. Oh boy, how small is chat for you guys on the screen too? I just realized it looks super small on my screen and I can't tell if it's that small for you guys as well. Okay, we'll do this for now. I'm gonna have to fix all that stuff up a little bit more in a moment. Or not in a moment, but after the stream. Hopefully I'll remember. If I don't, you guys will have to remind me. Why Nyko? Talking about errors, I remember there was a guy which was making a site specifically to make C++ errors more readable. The site would organize even to make the errors clickable. Nice. Which would redirect you to the exact line of your IDE. It's small, yeah. Yeah, I know I watch Zoding daily a lot, and I know he doesn't even show chat messages. And I kind of wonder whether it's necessary or not. I don't know. I do like having chat messages up there just because I think it's nice to have. And I feel like they need a background. Oh, man. I will have to fiddle with this a little bit after stream. Sorry about that, guys. I will fix it afterwards, though. But yeah, C++ errors can be pretty bad, but I feel like once you get used to them, it's not too horrible. It's not that bad, not that necessary. Yeah, I need to mess with my stream settings. It's been a while since I've messed with anything on stream, so yeah. And it consumes quite a lot of space. Yeah, and that's what I was wondering too. That's only your opinion. Your opinion is valid. I think I may debate taking it out. Let's do it. Let's try it out for this one. I'm going to disable them for now. We'll see how it goes. If I get complaints on the VOD or uploading it to YouTube, we can change it. I'll leave the topic there just so that that's still visible. Yeah. Okay, anyways, check if any of the physical devices meet. We have checked that. Next section will introduce the requirements. To evaluate the suitability of a device, we can start by querying for some details. Nice. I am lost. Okay, we're in here. So we're going to get our device properties. We're going to store them in here. The support for optional features like texture compression, 64-bit floats, and multi-viewport rendering, useful for VR, can be quite useful. Ooh. Didn't even think of this. See, this is one of the reasons why I kind of wanted to look into Vulkan. There's so many things where I felt I'm starting to feel held back in OpenGL, and it's kind of annoying. Gnarly Quack, it's kind of useful to know how behind chat you are. And if you're posting the videos on YouTube to have context, if you're talking to chat, but otherwise. Yeah. Yeah. And that's why I kind of feel like they should still be there, but they do take a lot of space on the screen. I could potentially, I don't know. I'll have to play around with it after stream. I'll experiment with it for the rest of this stream since there's not much left anyways. Yeah. And he already reads the messages. I don't think it's really necessary. Yeah. If you're watching this on VOD or on YouTube, let us know in the comments if you think it's annoying that you can't follow along with this conversation anymore. I think that the topic is the least important thing here. It is in the stream title. Okay, so let's go. Okay, so let's go hide the title. See how this looks real quickly. And we will put this stuff back here. Let's make that a little bit bigger. Grab this. Like, I wish I could just make my background. Let's go ahead. I'm going to change this up a little bit real quickly. Properties. Nope, that's not what I want. Can I just add a box in Streamlabs? Color source. That's what I want. Okay, if I do that. Whoops, that's fine. Nope, let me grab that. Okay, I think this is, you guys will like this, hopefully. Okay, let's do that. What is going on? Streamlabs, you don't know what you're doing, I don't think. Okay. Let me just change this up. Okay, this is, okay, let's try this again. I promise I'm getting there, guys. Okay, so we'll do color source, that, new source. Okay, there we go. We will make this dark mode. Okay, we'll drag that there. Drag this here. And oh, I hate how Streamlabs, like, I can't resize stuff unless I alter the aspect ratio, which is really annoying. Let's try that. 200 by 400. Okay, cool. That looks like it's matching up pretty good. Okay. Here we go. I need to move this stuff over a little bit more to the right, but does the chat, like, does the messages look big enough to you guys as you're watching them? Okay, let's move it over a little bit more. Yeah? I think this is better. Possibly. I'll see what you guys say. I think the topic is least important thing here. Okay, so no topic, chat, kind of ugly background for now. But if this looks good to you guys, I'll modify it a little bit more after stream and we'll see how it goes. Okay. So what were we doing? We were looking for features that we want in our device, which I think we did get physical device properties, and we want to get the physical device features as well. Yeah, it's better. Okay, cool. I'm hoping that background will probably be a little bit easier to read and stuff too, at least for you. Okay, we'll see what people are thinking. There are more details like being queried from devices. I think it's better too. Sweet, awesome. It's great. Okay, cool. This is good to hear. I'll have to change it up a little bit, get a better background in there and stuff. Yeah, we'll fix it up a little bit afterwards too. Okay, more details that can be queried from the devices. We'll discuss that later. And queue families. As an example, let's say we consider application only usable for dedicated graphics card. that support geometry shaders. Then the isDeviceSuitable function would look like this. Return equals discrete GPU, and we have geometry shaders. Instead of just checking if a device is suitable or not and going with the first one, you could also give each device a score and pick the highest one. Nice. That way you could favor a dedicated graphics card by giving it a higher score, but fall back to an integrated GPU if that's the only available one. You could implement something like that as follows. Why are we using a multi-map here? We could just use like an index, which is our highest score or whatever, and then like a highest score instead of storing them all like this. You don't need to implement all that for this tutorial, but it's to give you an idea of how you could design your device selection process. Of course, you can also just display the names of the choice and allow the user to select. Because we're starting out, Vulkan support is the only thing we need, and therefore we'll settle for just any GPU. I will just make sure it's a discrete GPU. So what we'll do is, yeah, I'll just say device features dot. I mean, I don't, okay, this doesn't matter too much because I don't even have any integrated GPU on this. I just have a discrete GPU. So we should only get one. If I get, at least, actually, I might have an integrated GPU on the CPU. I don't think I do. I guess it is possible though. Oh, I actually need to call that function. So yeah, I think this is definitely multi-draw indirect. Interesting. That's an OpenGL thing. Yeah, I think this is the correct one. What is this? Device properties. Yeah, okay, so RTX 28. Cool. So that is correct. That is the one I want. So I am fine with that. And we shouldn't get any errors. Cool. In the next section, we'll discuss the first real required feature to check for. Queue families. Next project, coding a Twitch overlay that blitz chat messages in random locations on your on my screen. That'd be fun. I know Vimlark, he has the monkeys, and I've been wanting to try something like that because I think that's really cool. How he lets people watching kind of run around the screen and stuff. I wish I could develop with Vulkan, but my GPU isn't Vulkan capable. Yeah, that's a bummer. I wonder if you could update the drivers. Sometimes if you update drivers, it works some magic, but I guess certain integrated GPUs and stuff may not be capable. Yeah. And GPUs are hard to get right now, which is not good. So it's briefly been touched on. Almost every operation of Vulkan is a 2010 iMac. Yeah, that's going to be a little bit trickier. Does Vulkan support Apple too? Because I noticed they didn't say anything about Apple. They just talked about Windows and Linux and Android, but they did say iOS. So I wish I could play with graphics programming at all, but every time I try, I just get burned out with the boilerplate thing. Once you get no, I was gonna say once you get past the boilerplate, it's not that bad. It's pretty bad the whole time. There's just so much boilerplate all the time, but I guess since I came from Java, kind of helps a little bit in that regard. No offense to Java, but Java is very verbose. So yeah, and corporate programming in general, I guess I should say. Yeah. It's briefly been touched upon. Almost every operation in Vulkan, anything from drawing to uploading textures, requires commands. Makes sense. There are different types of queues that originate from different queue families, and each family of queues allows only a subset of commands. For example, there could be a queue family that only allows processing of compute commands, or one that only allows memory transfer related commands. Cool. This is actually something that I kind of wish I had in OpenGL right now for my Minecraft game, because I would like to transfer geometry on a separate thread, but I have to do synchronization, which is kind of annoying, and I have to do all this mapping and stuff, which I'm assuming I'll still have to do in Vulkan. But I feel like it would be a little bit easier if I could have a dedicated thread for memory transfers, which would be really nice. We need to check which queue families are supported by the device and which one of these supports the commands that we want to use. For that purpose, we'll add a new function, find queue families, that looks for all the queue families we need. Right now, we're only going to look for a queue that supports graphics commands, so the function should look like this. Okay. Let's actually static that boy and copy that. Is device suitable? And that. And that. However, in one of the next chapters, we're already going to look for yet another queue, so it's better to prepare for that and bundle the indices into a struct. Cool. I kind of want to start abstracting some of this stuff out. Let's do that real quick. Because this is just, I don't like having all this in one file. I don't even know. There's a lot of different stuff going on. I guess it's all kind of just concerned with Vulkan stuff, so I guess it's fine in one file for now. We'll worry about that later. Q family indices. This is our structures. Okay, graphics family. Oh, and we have to find Q families. Man, there are just lots of things here. Okay. So we had, what was it called? Something up here. Yes, find Q families. Oh, okay. So we just changed the definition of this. That makes sense. Okay. What was that structure called? Let's go back up here. Okay, so we're just returning that instead. Cool. Okay, so what if a Q family is not, wait, why is this not a type def? I'm assuming the structure will have more stuff added to it later. And that's why we're not just type defing it. Okay, yeah, that's why he's saying bundle them into a struct. Okay, that makes sense. Cool. What if a Q family is not available? We could throw an exception in find Q families, but this function is not really the right place to make decisions about device suitability. For example, we may prefer devices with a dedicated transfer Q family, but not require it. Therefore, we need some way of indicating whether a particular Q family was found. I'm just curious, what are the chances that a user is going to have 5 GPUs and you're going to be looking for, oh, I'm scoring this GPU better than that one, and I don't see the usefulness of going quite this low level. I feel like there should be some sort of abstraction just around this stuff at least, because it doesn't feel like a common use case to me. But yeah. I've heard of Molten, but Apple has theoretically locked down their OS, so you can only use Metal. Yes. You can still use OpenGL. It just gives you a bunch of deprecation warnings as far as I know. How long will the stream be? I will probably be streaming for another like 10 to 15 minutes at most. Yeah, let's get to the end of this article, and then I'll probably lock it off down there. We are still quite far from drawing. I guess this is going to be like a 4-week thing if this is the pace we're going to go at. We'll see. I found that if GPU supports Metal, it supports Vulkan as well, not under Mac OS. 24-hour stream rendering a triangle in Vulkan. How's it going, Voxrifts? Surely not 0. Okay. So... and for Voxelriffs and anyone else just joining, yes, we have only made it past our validation layer. So, and we found out that Rockstar has hijacked my computer and are throwing errors somewhere up here. Man, I feel like that's grown. For the Ghost Rockstar JSON file, I didn't do it, I promise. I hope I didn't do it. Okay, anyways, it's not really possible to use magic value to indicate the non-existence of a Q family, since any value of uint32 could in theory be a valid Q family index, including 0. Luckily, C++17 introduced data structure to distinguish between the case of a value existing or not. Optional. Nice. Yeah, or you could just use uint32 max. I don't foresee them using that, right? I mean, yeah. What is optional anyways? How do they implement that? I am curious. This is why I hate looking at template code, because And why is this like a full-on class? If anything, I feel like this should just be... Like, there's so much stuff to this. If anything, I feel like an optional thing should just be like... something like this, right? And then... that... and... that. I guess maybe you couldn't do it at a union. So just something like that. Like, why is it not just this? Is what I guess my confusion is. And I have this declared wrong somehow. Oh, that should be that. That's not what I meant to do. Yeah, like, why is it not just that? This just seems so much simpler than whatever they had there. All that template magic. I don't know. Okay, anyways. You can still use OpenGL. Absolutely true. I'm on Linux, so I have an entirely different set of problems. Okay, I'm just going to use UN32 max for our invalid option type. We can actually kind of encode that too. So we can just say like... And then if I start seeing errors pop up where that shouldn't be happening, we can always just check that. So that's fine by me. No need to do an optional and complicate things unnecessarily, in my opinion. Co-fifths started learning looking into C++ today. What's going on? How's it going? We are in the middle of implementing or trying to draw a triangle with Vulkan, but definitely not going to get there today. Contrary to what I believed when I started this. Okay, you're an Arch user now. Nice. I've got to queue up the meme. I don't have the meme though, so. Okay, let's see. VK physical device. Okay, we can now begin to actually implement find queue families. Nice. The process of retrieving the list of queue families is exactly what you expect and uses get device. Okay, I know I said I'm just going to go to the end of the section. We're going to try and get to the end of this section too by the end of the stream so that we can at least start on presentation next week when I start this again. Okay, so with that out of the way, process of retrieving the list of queue families is exactly what you expect and uses get physical device queue family properties. That's exactly what I would expect. I'm hoping you guys would have expected that as well. So, once again, I am going to manually allocate. And nothing against the author too when I say stuff like that, because I have noticed whenever I record tutorial videos, I will say stuff like simple, right? And I will be talking about something that is absolutely not simple. So nothing against that type of writing style. I am very guilty of doing similar things, if not worse. Okay. So we get the count, we allocate that, we fill it, and now we're good. So then we loop through the properties, of course. If we need the index, we may as well just use the index. So family I equals 0. That's wrong. Family I. Okay. We will do that. That is a VKQ family properties. Make that const. And this is actually going to be a const ref. Okay. Get rid of that. We will call that. Indices. And I'm guessing that's our result. Okay. And I guess what we want to do is like initialize this to null Q family. Cool. So yeah, that works out. Why you know Arch games with K? I'm just like plain vanilla Ubuntu, right? Ubuntu's a flavor, I think. I don't know. Just like whatever the most generic Linux distro is, that's what I use. Sway plus Wayland is my favorite now. Yeah, I'm not very good with lots of Linux distros and all that stuff. I just know a basic enough to be dangerous. We'll leave it at that. Okay, so we've got all that stuff. Now we want to, so now that we have this fancy Q family lookup function, we can use it as a check in the is device suitable. Wait, so what are we even doing here? Completely forgot. So we have this Q family indices thing. Logic to find the graphics Q family. Okay, so then we get Q family count. Okay, so we're checking to see if we have a Q family for our graphics bit, and then we're saying our graphics Q family is equal to this. Okay, so let me just write a note. Note, we look for a Q family suitable to store graphics commands, which is our requirements for a suitable device. Okay, I think that's what we're doing here. So now we can use it here, which is right here, is device suitable. And I guess we don't really need to look those guys up. Well, I mean, I guess we could use these to do. Can use these and check for certain properties, but we don't care about that right now. Does not equal null family, null Q family. Okay, so that's all we need to do. And we should be good. Cool. To make this a little bit more convenient, we'll also add a generic check to the struct itself. That's unnecessary. Well, okay, I see what he's doing. He's setting up for a bigger thing. And we may as well just do that. Okay, cool. We can now use this and early exit from find Q families. Ah, okay. I guess that makes sense. Yeah, and I'm not going to return because I still got free stuff. Okay, so we do all that. We look for a suitable device. We pick a device, and I am going to log once we get a physical device. Info found suitable device, and we will print out our name, which is going to be no, that's not right. Can we do that? Dot? No, we need to get the properties, which is that stuff. So we'll just do this for now. That. And I think we just need that. Yeah, we're just going to use that. Okay, so we do all that. We do all that, and I think we do call this already. We do. Let's make sure this all works. We should see my GPU pop up once this returns a value. We should see my GPU pop up, and we should be good. So we got successfully initialized Vulkan, found suitable device, and it gives me my device name, RTX 2080. Sweet. Works good. Let's check chat real quick. Linux stuff. There are depressing few games being released for Linux. Maybe that'll change with the Steam Deck. Yeah, okay, I see your second half of the myth. Well, no, yeah, I think that might change with the Steam Deck since that uses Linux as its base, at least I believe. I'm still not sure what's happening with that. Does anybody have a Steam Deck and use a Steam Deck or not? Proton and Wine are impressive. That's true too. Very impressive what people have done. Logical devices and queues. Introduction, specifying device queues. The queues to be created. Use device features. Creating logical device. Retrieving queue handles. Easy. All right. Okay. So after selecting a physical device, we need to set up a logical device to interface with it. The logical device creation process is similar to the instance creation and the features we want to use. We also need to specify which queues to create now that we've queried which queue families are available. And you can even create multiple logical devices from the same physical device if you have varying requirements. Okay, so let's create our logical device for our physical device. There's a reason I named this project Vulcan Begins. Okay, so let's call this our logical device just to be explicit. Alrighty. So we need to add a create logical device function and call it, of course. Let's do that. What did I just do? Okay, I don't know what I just did there. I hate it when I accidentally press a random key press and it just does weird stuff. It's like when you do something in Blender and you're just like, I have no idea what I just did. We'll do that. Pick physical. There we go. Nice. And we want to put that below our pick physical device. All right. Let's just go back up here. Okay, that's good. That's good. We're good. Cool. Specifying the queues. Okay, so the creation of a logical device involves specifying a bunch of details and structs again, of which the first one will be create info. More create info. This structure describes the number of queues we want for a single queue family. Right now, we're only interested in a queue with graphics capabilities. So we want to say indices, find queue families for our physical device. Queue create info. So then we zero initialize that. And we are just going to grab that. Queue count 1. Okay, so we're basically just grabbing the one queue that we've asked for, which is our graphics queue, and we're setting that up. The currently available drivers will only allow you to create a small number of queues for each queue family, and you don't really need more than one. That makes sense. So we only want one queue per family. Makes sense to me. It's because you can create all of the command buffers on multiple threads and then submit them all at once on the main thread with a single low overhead call. That is interesting. So even though... That's interesting. So I wonder if you can only submit commands on the main thread or if they do that just to minimize multi-threading mishaps and stuff. Yeah. Wait, I see my name. Having finally found the one true graphics card is now tasked with taking it to Mount Doom. Presses a random key and suddenly teleports to another dimension. Very true. I like the commentary. NVIDIA is finally open sourcing their drivers for Linux too. Never thought it happened. I did see that a while ago as well. Okay, Vulkan lets you assign priorities to queues to influence the scheduling of the command buffer execution using floating point numbers between 0 and 1. This is required even if there is only a single queue. So we have our queue priority. Wait, did I do this? Yeah, I did do this. And I guess we need to pass it in a reference, which is why they do this. Okay. Specifying use device features. And so what's 1? Is 1 like lowest or highest priority? Using floating point numbers. Yeah, I'm not sure if that's highest or lowest priority. But yeah. Interesting that the priority is a float. Yeah, it kind of makes sense, I guess. No, I think I do agree with you. Because technically, like 0.99, like, is that true or not? I don't know. Yeah, because see, it rounds it to stuff like that. So kind of interesting. Between 0 and 1. Well, actually, wait, I am curious now. Is 0.99 less than 0.999? True. Oh, okay, cool. So it does. What if we do 1? True. Okay, cool. Just curious. Okay, that was technically double us too. Didn't mean to click there. Oh no, did we lose our place? It's okay. We were just right here. So, specifying use device features. The next information to specify is a set of device features that we'll be using. These are the features that we are queried support for with get physical device features in the previous chapter, like geometry shaders. Okay, so right now we don't need anything special. We can simply define it and leave it to false. We'll come back to this structure once we start doing more interesting things. Okay, so no device features for us. With the previous 2 structures in place, we can start filling in the main create info structure. I mean, I guess I could just go through and like copy paste all this stuff, but that wouldn't be fun, would it now? Okay, so this is our create info structure. Wow, how is this different? Okay, so this is our queue creation info. This is our device creation info, which we specify there. We give it our queue creation info. Okay, that makes sense. And then we give it how many queue creation infos we have in there. Okay. The remainder of the information bears a resemblance to the VK instance create info struct and requires you to specify extensions and validation layers. The difference is that these are device specific this time. An example of a device-specific extension is the VK KHR swap chain, which allows you to present rendered images from that device to Windows. It's possible that there are Vulcan devices in the system that lack this ability. For example, because they only support compute operations, we'll come back to this extension in the swap chain chapter. Cool. Previous implementations of Vulkan made a distinction between instance and device-specific validation layers, but this is no longer the case. That means that enabled layer count and PP-enabled layer names field of VK device create info are ignored by up-to-date implementations. However, it's still a good idea to set them anyways to be compatible with older implementations. Okay. So we're enabling 0 extensions for now, unless we're enabling validation layers, but then that's just the layer count. Oh, and we just give it the same validation layers, which is interesting. Huh. Just don't set a priority of 0.3. Not sure which numbers Float has a hard time with. That is true. When you boot a Linux install on different hardware and your C++ project doesn't build. Oh. That happens to me like half the time when I boot it on the same hardware. I guess I just don't have good C++. I don't leave my C++ projects in a good state, I guess we could say. We won't need any device-specific extensions for now. That's it. We're now ready to instantiate the logical device with a call to the appropriately named create device function. Awesome. And we're giving it logical device. And I'm just going to say VK results, which it mentioned this, lowercase k for types, uppercase for enumerations, and lowercase for functions, which is interesting. And then what we'll do is we will just say that, and then glogger assert VK success, and we're good there. Yeah, we just want to get rid of that. Cool. So we assert that we succeeded. The parameters are the physical device to interface with. The queue and usage info. I really need to get like critical asserts into my assertion library because right now I don't have any distinction between the two, and there really should be. So I can turn certain asserts off at runtime. Anyways, side feeling or side point there. Doesn't find one single Qt header. The parameters are the physical device to interface with. The queue and usage info we just specified, the optional allocation callback pointers. Okay, so he's just explaining the things. And then we need to destroy the device. Makes sense. So when do we want to destroy it? Before everything else. Let's also just kind of do that. Okay. Retrieving queue handles. The queues are automatically created along with the logical device, but we don't have a handle to interface with them yet. First, add a class member. So like this stuff all kind of makes sense. It's just a lot of stuff to remember, but none of it is inherently difficult. Like, yes, it makes sense you want a graphics queue. It makes sense that you want a queue for these different things. And I guess once you do it once and figure out how to create one queue, it's like, okay, I need to create this queue now, and you just need to look up the documentation and kind of set that stuff up. Also, just out of curiosity, what build system am I using? Because it doesn't seem to be CMake, you think. It is not CMake. It is Premake, but I plan on switching eventually because there's quite a few problems with Premake that are just obnoxious. It's not issues with Premake, but it's issues integrating with other things from Premake. But this is what I have to do, which is just a bit more than I would like to do. So yeah, I just do that, and then I have a build batch which just executes Premake and stuff and then gets all that set up. Yeah. So the queues are automatically created. Yep. Device queues are implicitly cleaned up. So that's cool. When the device is destroyed, so we don't need to do anything in cleanup. We can use the getDeviceQueue function to retrieve handles for each queue family. The parameters are the logical device, the queue family, the queue index, and a pointer to the variable to store the queue handle in. Because we're only creating a single queue function, queue from this family will simply use index 0. Oh, cool, and that's the end of this. Awesome, we're almost there. Let's just make sure we get this right. So I'm assuming we want to do this at the end of our find queue families. Nope. So we want to do that at the end of our logical device creation. I don't even know. I guess I'll put it up here for now, and then we can move it around if we want to later. But what do we call that? Graphics queue? Yeah. So, and what is the function called? VK getDeviceQueue. So getDeviceQueue, and basically we want to give it our device, which is our logical device. We want to give it our family index, which is our queue families. But what did we call? Oh, I think we just called it indices. What did I call it? It's somewhere up here. Okay, so we have queue family indices. I don't actually save it anywhere. Okay, so I guess we should probably put this wherever I have that. So when we're creating the logical device, which makes sense. Okay, so we'll do it here. And we want to give it our graphics family. We want to give it our queue index. Oh, wait, this is the queue family index. So this would be VK queue family. And this is our graphics queue. VK graphics queue family. No, let's check what he uses. Okay, no, so that is, okay, we're passing 0 in for that second one. What is that second one? Indices.graphics family. Queue index, which he's doing a 0. So I guess that's the index within like our global buffer thing. Wait, here. So we do that. I think this is basically like we have a list of queues, right? And then we're saying 0 is our graphics queue. And then if we want to do like 1 is our memory transfer queue, we could do that, and then we could do that, and we could say like something like that, right? At least that's what I assume would happen. And then this would be 1. Just double check that and make sure I am understanding these things kind of correctly. Queue index. Yeah, okay, so I think that's what that is. Oh, wait, this is get device queue. I think we want... Oh, yeah, get device queue. Oh, wait, did we just store that in 0? I'm guessing that's what's happened. We've stored that in location 0, and now we're getting it from location 0. Let's just double check. Because I want to make sure I kind of understand this a little bit before wrapping up. We do that. Family I is less than that. Okay, so technically... Okay, wait, where is this? This is coming from here. Okay. This is coming from here, which does that. And then we do that, which is that. Okay, what about this? So we do that, pick physical device. Yeah, I don't know exactly what tells it. I guess it's just the way, oh, maybe it's because of the way we do this. Since we're giving it this queue create info, this is located at index 0. And since we pass it in here, yeah, we pass it in, no, not there. We pass it in here. We say there's 1, but I'm guessing this is a pointer. So technically what we're really doing is we could say this star equals G memory allocate size of VK. Wait, no, that's the wrong thing. Okay, we don't want to do that. That was fine. Right here equals that times number, I guess we'll say number Q families, right? And then we have our that. We can set that there. We can set I think this is right. Wait a second. I just want to make sure I'm okay. So then we would change that. This would be that. Okay, then this would be 0, right? Because now we're setting up 0. Okay, this makes more sense to me now. And then that would all be 0. So now what we're basically saying is since this is index 0 in our queue creation, that's why we're using index 0 here. Okay, I understand this a little bit better now. I am happy with that level of understanding. Let's make sure I didn't break a bunch of stuff. And then I think we're good. Okay, that's not good. I did break something. These are all just logs though. Okay, what's going on? Physical device looks fine. Logical device does not look fine. Yeah, but we're passing logical device. Wait a second. Do I need to set logical device? I think I need to 0 it out. I think that's what I'm missing. G memory 0 mem that. Okay. Oh, and we also need to say that. See if that works. Okay, and we got success. Cool. So we just need to 0 out that memory. Sweet. Okay, and we have a memory leak detected because we're not freeing this at all. I don't know if we need that to stick around, but we're not letting it stick around. Cool. So let me just check chat real quick. Been playing a bit with Xmake. Interesting. I haven't heard of Xmake till now. Didn't have any problems so far. You don't want to pass a reference in then, right? It's already a pointer or take reference. Yes. So we did fix that. No memory leaks. We are good here. Cool. So that's the first part in our Vulkan series for drawing a triangle. Okay. I know Tantan made a video a while ago, which was like what did he call it? It was like speedrunning triangle creation for OpenGL. You guys need to go like comment on that video and be like, we all need to go comment on that video and be like, okay, do a speedrun with Vulkan now and upload it to YouTube. I'd be interested. I don't know if he's done anything with Vulkan or not. But yeah. Finish setup section. I forgot to commit the other stuff. Oh well. We've done pretty good so far, so cool. Okay, so we've kind of gone through, done the first couple things. So next up would be presentation, which is setting up all the window stuff, which is kind of small. And then we've got that, which looks pretty big, and that. So we might try and knock these two out together since this one's a little bit smaller in the next stream, and then finally get the drawing done. But yeah, baby steps. I like it. That is true. Thank you guys all for coming and watching, though. Hopefully you enjoyed this. Go enjoy some time doing whatever you like to do. Go read, go play a game. That's fine with me. I'm probably going to go and relax for a little bit. But I'll see you guys next week, probably around the same time. If not, I'll leave a message in the Discord and let you guys know what the time will be. But yeah, I'll see you guys next time. Thanks for watching.